Okay, hello everybody. My name is Angelo Herrera. I'm from the Minneapolis office, and today we're going to cover short channels with Mahi Paul from our Berlin office. And whenever he's ready, he will go ahead and begin.
Thank you, Angelo. Hello, everyone. My name is Mahipal, and welcome to this webinar on setting up short distance measurements with NIRx devices. So let's take a quick look at the topics first. Start with some basics, and we'll briefly look into why should we use short channels. We'll also look into the principle, the working principle behind short channels, and then we'll also see how they are integrated with NIRx devices. As a first step towards using short channels, we'll take a look at creating montages with short distance detectors in our montage design software NIRSite. From the hardware side, we'll see how to place short detector probes on the cap. And once we have our hardware ready, we'll then move on to set up data acquisition with short channels in NIRStar 15.2. This webinar will not cover the data analysis of short channels. This part still has to be streamlined, and this will be a topic probably somewhere in the future. But lastly, we will have some time for any questions you may have. So let's get started. Now, some of you might say, hey, I'm quite happy with my measurements. Why do I need to look into short distance channels? And to answer that, let's look into NIR's signal obtained using our standard distance channels. Our 3 centimeter standard channel has two main contributors, the extracerebral and the cerebral components. Therefore, our FNIR signal is composed of vasomotor or Meyer waves, which is the blood pressure component. Now, the frequency of these waves is around 0.1 hertz, which is very close to the hemodynamic response function. If you try to remove these components by band pass filtering, for example, there is a possibility that we might also remove some of our signal of interest. We also have respiratory components embedded into our signal. The heartbeat, which is about 1 heartbeat per second. And of course, our actual hemodynamic response signal. And in addition, the measurement noise, which is inherent to the acquisition systems. And so, in recap, we would like to infer cerebral changes that are typically evoked responses and are of neuronal origin. However, the signal we measure with standard channels, although gives us a very good estimate of the neuronal response, it does have several confounders embedded into the signal. And this brings us to the task of how can we regress then? How can we get rid of these confounder contributions from the near signal to estimate the real hemodynamic response? And for that, we have just a solution for you, and which is the short distance channels. And although you could potentially look into algorithms such as principal component analysis or something similar to get an estimate of extracerebral components after acquiring your data, however, considering the local effects, we believe the short channels have slight edge over the post acquisition methods. And the theoretical basis of this concept is the fact that systemic components are global in nature, which means that the blood pressure, the heartbeat, and the respiratory components are present all over the brain, whereas the hemodynamic response is quite localized. And given the fact that the distance between a source and detector is directly proportional to the depth of photon penetration, our standard channel will contain both cerebral and extracerebral contribution. But if we place a detector much closer to the source, that is, if we reduce the distance between a source and detector significantly, the signal we measure will contain just extracerebral contribution. And once we have that, we can then regress this extracerebral signal from our standard channel signal to get a fair estimate of the hemodynamic response function. And let's see how it looks in practice. So you can see that this is our standard detector, an LED source. Both of them make a standard channel. Around this source, we place our short detector clip, making a short channel with the source. So in the yellow, you can see a normal 3 centimeter distance standard channel. And in the purple, you can see one of our short channels. These are our short detector clips. These clips replace the base of spring holders and they sit around the source. The yellow circle bumps you see are rubber feet to balance this short detector clip. But the last ones, the ones which are marked in purple, are two different fiber optics at two different locations, but they both join to form one. So basically, we are measuring the average of 2 points. And why do we use two fiber optics in these short detector clips? Firstly, if you double the fibers, you get a little bit more light. And since these are small fibers, they pick up much less light than our regular detector fibers. Secondly, we would like to avoid any local effect. For example, if there's a hair or a vessel just crossing under one of them, a point measure would be more sensitive to these kind of local effects. But if we have two, then this effect will be averaged out. One more reason for this is they compensate for, let's say, misalignment of dual tip sources. So if by chance one of the dual tip is skewed, then having only one tip might affect the signal reception. And how they are implemented into a bundle, what we do is we have so 8 rings on one side are all funneled into one output, which then would be connected to a detector, which could be single or dual tip, could be a near sport active detector or fiber detector for our desktop systems near Scout. If you have seen a short detector bundle, you will find that in one bundle, we will have 8 of such short detector clips, which are then placed around 8 different sources, again, which means forming 8 short distance channels. This also implies that we have to sort of sacrifice one of our standard detectors. And this sacrifice detectors, uh, in this case, is always the last standard detector. For example, for an 8-8 configuration, detector 8 will have to be used to connect short distance detector bundle. Um, and if you think about it, this is a very economical solution in the sense that you give one detector channel to generate 8 short detector channels. For example, for a near sport measure, you go from 8 source 8 detector measure to a 8 source 7 detector measures. Plus, you generate 8 short channels. And now, how will it work? I mean, how will the software know from which short detector clip the signal is coming from? For this, the short distance detector system utilizes something called time multiplexing. Let's look into that. On the top left, you see this illumination pattern. You must have seen this. You can't miss this in NIRStar, which means that on the top axis we have source number from 1 to 8, and on the sort of y-axis we have step number also 1 to 8. And this means that with each step, only one source is activated. So what will happen is first source 1 will be activated. And in this case, then the short detector clip, which is attached to source 1, will pick up the signal, and the signal will be then transmitted to detector 8. And since our software already knows that at this instant of time, source 1 was activated, then the signal could have only come from the short clip attached to source 1. And then in the next step, source 2 is firing, and then the short detector clip, which is attached to source 2, will collect the signal, and then this signal will be then transmitted to detector 8, and the software knows at this point of time source 2 was activated, So the signal could have only come from the short clip attached to source 2. And similarly, when source 3 is activated, detector 8 receives signal from short clip attached to source 3. Next step, source 4, 5, 6, 7, 8. You get the idea. So in one scan, we have all the sources activated step by step, and then signal is collected from the short detectors placed around these sources. The smart thing about time multiplexing or source multiplexing is that we can route all these short channels to this one detector. And because there's only one source which is firing at a particular instant of time, it will prevent any crosstalk. Um, Another advantage of time multiplexing is that we could adjust the gain dynamically. Since we have only so much control over how well the shot detector makes contact with the head, different shot detectors may give different coupling efficiency. However, since each one is looking at different sources, when you switch over to the next source, this detector can adjust the gain. And to create these short channels, now we'll have to move on to creating montage in NIRSite. So before we start designing our montage for short distance measurements, we have to consider something important. As we have seen in the previous section, the last detector is sort of sacrificed in order to connect the short distance detector bundle. So similarly, when designing a short channel montage, we have to omit this last detector from our montage. So if we consider this 8 by 8 motor montage, detector 8 on the right side has to be omitted when we move on to NIRSite. Now obviously, removing this detector will cause an asymmetry in our montage. The right part of the head has now lesser coverage as compared to the left part. So we have to be careful of this fact, and we might want to redesign our standard montage in order to get the desired head coverage. So you have to decide which detector and head positions you can afford to lose. So keeping this in mind, we can move on to NIRSite and design our short distance montage. So what we will do here is we will take one of our standard motor 8 by 8 montage. So I go to load, I go to C drive, NIRx, and find my standard montages. And from the standard montages, I load my motor 8.8 montage. As you can see here, I have 4 detectors, 4 sources on the left side, 4 detectors, 4 sources on the right side. And as we discussed before, the first step would be to delete our last detector. So I go ahead and find my last detector, which is on the right side, and simply remove this. We can see that removing the last detector also removes 2 of our channels. We have discussed this before. You would like to rearrange your montage in such a way that you have your desired head coverage. And once we have done that, we can proceed with placing shot detectors around our sources. Uh, I would also like to point out that the order of placement of shot detectors is not important. The order is also not important when you place shot detectors in the gap. We will see that in a while. So I just go ahead and we can proceed with placing shot detectors around our sources. I have here source 8. I will go ahead and simply place a shot detector around this source. And the distance between this source and the detector should be around 8 mm. And to check that, we can go to channels. Since we have 7 standard detectors, the 8th detector will be our shot detector, and the distance between detector 8 and source 8 is 10.7. Ideally, you would like to keep this distance somewhere around 8 mm. With this version of NIRSite, you have to play around a bit. You have to do a few hit and trial to get this distance around 8 mm. However, we will soon release a new version of NIRSite which will place short distance detectors automatically. So most probably this will just be a button click which will then place short detectors around the sources. So we can move back and place short detectors around all our sources. So I do the same with source 7. I move on to this source and place a short detector here. So for the right side, we have placed 4 short detectors around our sources. We then move on to left side and we do the same. So my source 1 is here and I go ahead and place short detector around source 1. I do the same with source 2. We move on to source 3 and place a short detector. And finally, source 4 will also have a short detector. And this is it. We have now placed short detectors around all of our sources. The next step would be then to save this montage. We always save these montages in the standard directory alongside with our standard montages. So I go to choose directory, C, NIRx, I find my montages folder, and then I create new folder. Let's call it motor sdd 88. Once we have the folder, we can just save our montage, which will then create a probe info file, which can be then used for further analysis. And this is how you create short distance montages with NIRSite. The next step would be to place physically the short detector clips in the cap. And for that, I have a video showing how to place them. We'll see the video, and in the meantime, I will talk about what's happening in the video. So let's get started. If you have ordered a short detector bundle from us, you will have 8 short detector clips. These clips are, of course, connected with a common end. There will be coupling tubes for single and for dual tip detector probes and their respective screw caps. We also provide rubber sleeves and retaining rings, which are useful for sensitive regions and sensitive participants. And lastly, you will find some useful stuff for organizing fiber optics in the cap. So our short distance probe setup is a retrofit solution, meaning that the short detector probes can be used with the existing spring-loaded gromets. So if you already have a cap populated with holders for sources and detectors, identify the sources you want to place your short detector clip with, and simply proceed by removing this split retaining ring. We recommend use of the pliers which are supplied with your devices. And once the ring is removed, you can rearrange the fiber a little bit and just carefully slide the short detector clip from the side until it's fully seated. It's important that the clip is engaged all the way and that it's not caught, that it has not caught any fabric, as we see here. And if that happens, you could gently rotate the short. If a fiber is stuck, you see the base is slightly disoriented. And you can simply repeat the process for placing all the short detectors. The short channel detector fiber optics is routed underneath the cap. So it's important to use organizing clips to hold the fiber optics in place. And these clips, as you see here, can be positioned in any available free slits in the cap. So just place the clip with its slit on top of a fiber, just slide the wider portion of the clip into an available slit. You can cut additional slits in the cap if the number or positions are inappropriate for your setup. You could see the fibers are now held in position. If you still have an unoccupied position available, you could bring the short bundle outside the cap through an available slit as shown here. helps in organizing a bit. And once you have placed all your short detectors around the sources, we can now move on to connecting the common end of bundle to the adapters. And the interface between short bundle and detector is provided by coupling adapters. These are different for single and dual tips, so be sure to use the appropriate adapters. Um, the the dual tip will look more semicircular, whereas adapter for single tip will have a circular hole inside. To connect the short channel probes, insert the common end of the bundle into the end of adapter with an outer thread. You can see the thread here. Just place the tapped cap and carefully screw it into its place. Excessive force is not required here. And that's it. You have now connected your bundle with a coupling adapter. And next you can insert the detector, which will be the last detector of your setup. It's not clear, but it's detector 8 in this case. This is placed in the end with internal threads. And then again, make sure the detector is fully seated. Apply the screw cap gently until you face resistance. Again, no excessive force is required. To provide strain relief and to organize the detector bundle in a better way, use the provided Velcro clip. It could be attached to the base of the cap with the adapter seated inside. We'll see how to do that. So yeah, once you have your bundle out, you can simply open the clip and place the adapter inside this. And this is it. For a normal cap, you're all set hardware-wise to start your short distance measurements. In order to avoid discomfort in sensitive regions or for sensitive populations, we recommend the use of soft rubber sleeves that are available for short distance clips. We also provide rubber retaining rings for the surrounding detector positions. And to place this, so once again, proceed by removing the retaining rings. The same way, in this case, we are showing a headband because it's placed on the forehead, which is a sensitive region, and simply take your short detector clip and place it around the base. And as you can see here, the rubber sleeve has grooves, and these grooves will fit perfectly into the detector clip. Simply place the rubber sleeve and press it gently, and that's it. Similar to the rubber sleeves for sources, the package also comes with rubber retaining rings for detectors. And simply, again, remove the standard retaining rings and place these as shown here. And that's it with the cap setup. Once we have the cap ready, the montages ready, we can now move on to NIRStar and set up our software there. So there you see it, we have NIRStar 15.2. For this presentation, I already have a NIRSport 8.8 connected. I already have a headband ready for the measurements. And as with any other measurements, we would simply proceed and go to configure hardware. And the first thing you would like to do is just go ahead and click short distance measures. And as you can see here, I have 8 sources and 8 detectors because I have a NIRSport 8.8 system. We can only place one short detector bundle. And if we have more, we can specify here. And as I said before, short bundle is always connected to the last detector. So the software does this automatically. If you have only one bundle, then it says, hey, the detector bundle is connected to the standard detector number 8. So if you have, let's say, a 16 by 16 system, 16 sources, which means you can place 2 short bundles. In that case, if you increase this to 2, and you would see, okay, it doesn't show, but it should show 15 and 16 here. It doesn't show because I have 8 system. So once we have this, we can go and select a montage. I already have a montage prepared. It was prepared in exactly the same way as I showed you the motor 8x8 montage. We can go ahead and see we can't change anything here because it's a NIRSport. That's how it works. What you would see here is we specify a number of sources as 8 as we do, and we also specify number of detectors as 8. So regardless the short bundles are connected or not connected, the number of detectors will remain 8 here, and the sampling rate, of course, doesn't change. In my topo layout, however, this is a bit spread out, but that's easy to change. If you feel that I'm going through NIRStar rather quickly, please look into our webinar where Thomas talked in detail how to set up NIRStar 15.2. I'm only going to go through the features which are related to short channels. As you can see here, I have source 1, detector 8. I have one channel. Source 2, detector 8, I have my second short channel. Similarly, source 3, detector 8 is my third short detector channel up to source 8, detector 8. So this, when we run the calibration, we should see all these channels. What we can see here is in my channel list, or rather should go here. In this case, we won't select equidistance channels. It will still show 30 mm, but for example, for this also it will show 3 centimeters. But when I click on source 1, detector 8, I know this is my short detector channel, and this changes into 8 mm. So similarly here, source 2, detector 1, and when I go to source 2, detector 8 channel, this is my short channels. And we can go till the end. Source 8, detector 8 should also be a short channel. And this is it. This is what you have to do for hardware configuration. You come to short distance measures, you select short distance measures, you select the number of bundles. If you have a NIRSport 8x8, you can only have one bundle. If you have NIRScout 16x16, you can connect 2 bundles. In that case, you will choose 2 bundles. This will then change into 15 and 16 because the bundles will always be connected to the last detectors. Once you have created your montage, you should save it in the default montage directory, and you should find it among your standard montages. Once we have all these settings, we can go ahead. This says my topo layout has more than 15 rows and 10 columns. It's just a warning. Another pop-up appears which says you have enabled short distance measures. Please only proceed if you have connected the couplers to collect short distance data. So not only software wise, of course, you should have your short distance bundle connected to the cap. I press continue. And in this part, I will share my webcam and I will try to show you the placement of headband. Let me find it. It's here, everybody can see now. So I take my headband, which is already prepared. You can see here I have 8 of my short detector clips placed around 8 of my sources. So 1, 2, 3, 2 in the middle, and again 3 in the bottom row. So I simply take this, just place it, remove my hair a bit. I have slightly thicker hair, which might cause some problems. Place it around my head. Place the bundles behind. What I will do is I will also check if I have some hair still. insights. I will just scoop out any here I have which might be causing any problems. We can go to NIRStar, and as we do, we can run a calibration to see how our data looks like. And actually almost perfect. As you can see here, if you remember from the topo layout, my short channels are shown here. So this is the short channel with source 1, source 2, source 3, my short channel with source 4, my short channel with source 5 is here, 6 is here, 7 is here, and 8 is here. And I will repeat this. The placement of short detector clips on the head, the order is not important. You can just place them randomly. And you can see here that we don't say source 1, short detector 1. We only say source 1, short detector. And this goes back to the time multiplexing concept, which was that the software already knows that when source 1 was activated here, this channel could only receive data from the short detector clip attached to source 1. So we don't need to specify which clip was attached to which source. We just say source 1, short detector 1. Let's look at details of our calibration. Signal quality, the gains, let's see the values. I think they are pretty low. I'm quite happy with the results. Let's see the signal level. Apart from 1, which is still quite acceptable, I have signal in a good range. Let's take a look at the CV of the noise, and this is also quite acceptable. This is yeah, this is about 4% here, 7%. This I'm fine with it. I would expect high dark noise because I have a lot of lights over my head, but these are still okay. For both wavelengths, I don't seem to have any problem with the data. So once we have our calibration ready, in the next step, we can straight away go and record some data. I don't need to fill out any details. Let's see how our data looks like. And actually, it looks quite okay. I could also go ahead and show labels to show you that these are my standard channels, and you would, if you look carefully, you would see source 1 SD. So this will be channel 3 will be my short detector channel for the source 1. And for the source 2, I should have channel 7 here. For source 3 as well, I should have short channels, which are number 10, and so on. For every source, I have short channels. Let's go to the last one. As you can see, channel 30 is my short channel from source 8. Details about the data shown here, the online data, were also discussed quite in detail by Thomas in the NIRStar 15.2 overview webinar. So if you would like to know more, please refer to that webinar. For the short distance measures, I think we are almost set. We saw how to make montages. We then saw how to place the cap. how to place short detectors on the cap, and now we saw how to set up short measures in NIRStar 15.2. It's a pretty straightforward concept. I will stop the data. Let me see if I have missed anything. I think we are fine with NIRStar 15.2 setup. If you still have any questions, we probably have a lot of time to discuss that. And the last topic, which we are not going to discuss, is the analysis of short channel data. NIRSlab does not yet support analysis of short channel data. However, you could look into external sources such as Homer2 or NIRS Toolbox by Ted Huppert. You could look into forums. There are people discussing how to analyze short channel data, and in future, hopefully, we will be able to come up with some solutions regarding this. And this is the end of my webinar. We have a lot of time for questions.
We've had one question before the meeting, and it just asked if it's possible to buy the short channels already.
I think for that, I would recommend you to just write to us.
So who of you had the previous version of NIRStar that already partially enabled short channels, but not completely? There is a difference. So before, in the previous version of NIRStar, you had to manually enter, if you wanted the online visualization, the online calculated data of of hemoglobin, you had to input manually that the distance is 8 millimeter. And this is done exactly here where Mahipal is showing. So you go under hardened and HB parameters. So in the earlier version, this was not set. You had to manually enter for each short channel. Okay, these are actually not 30, but 8. And this is now automatically done if the short channel option is enabled. But the data, just like before, this is not taken into account when data are exported. So whatever analysis you choose to do, the raw data, of course, do not have information about the SD distance. Only the probe info file does. So if you have used a probe info file generated in NIRSite, as Mahipal showed, then this information should be available.
Someone asked, how do you proceed with short channels if you use the standard holders rather than the spring? And should they be changed to spring holders if so?
I think the short channel detectors can only be used with the spring holders. They don't work with the previous versions of holders.
Correct. So because they have to be used with the basis of the spring-loaded holders. However, since before we were suggesting to use AC or standard grommets in sensitive regions like the forehead, or on sensitive subjects like children or geriatric or bald people. Now we have springs of variable strengths. So if you want to do a measurement on the forehead, like Mahipal did, right? So you will use the basis of the spring-loaded holders, but you will not use the same spring tops as you would do it normally. So you can use much software, or as we call it, zero springs.
Mm-hmm. And if I can add, we will have different levels of pressures, so to say.
Yes, I think now it's different forces. So it's from 0 to 3, with 0 being very soft. So for most sensitive region, up to 3, which is the strongest spring.
Okay, then this brings us to the end of this webinar. Thank you, Lamia and Angelo, for joining us. And thank you, everyone who joined us live. And for the ones who couldn't attend the webinar and are watching this recorded video, please do reach out to us if you have any questions. Thank you and goodbye.